Guys, so having discussed the concept of permutation, we've seen how it works, right? Let's get to combination. What's combination? Combination is a set. Now look at now is a selection. For combination, take note of the root word selection. Permutation, we talked about arrangement, but here in combination we're talking about selection, right? A selection by taking what sum or all of the number of objects irrespective of this arrangement. To break it down, what it simply means is that combination has to do with selection of numbers, not arrangement. Permutation has to do with arrangement of order, arrangement in order, but we'll talk about combination, we're talking about selection. So let's take for instance that we have, let's say 10 fruits, right? Examples. Let's take an example. Let's assume we have 10 fruits here. Let's say fruit 1, F1, F2, F3, F4, F5, F6, F7, F8, F9, and then F10. These are 10 fruits. Now, how do we select 4 fruits and arrange them from the 10 fruits? Selection of 4 fruits from these 10 fruits. What are the possibility of selecting 4 fruits from these 10 fruits? Now, the possibility is very much. It's a whole lot. So, but because of time, I'm going to use the formula to explain how we can select using combination, right? So, the combination for our formula for combination and combination arrow. So that's for combination. What we have is simply n factorial over n minus arrow factorial, arrow factorial. So when we are selecting 4 fruits from the 10 fruit, we are simply saying how do we select 4 fruit from these 10. So what that means is simply 10 factorial over what? 10 minus 4 factorial, 4 factorial. Right? That means we are doing 10 factorial over 10 minus 4, that's 6 factorial, and then what? 6 factorial times what? Times 4 factorial. If we try and expand that, I believe we're going to have 10 times 9 times 8 times 7 times 6 factorial over 6 factorial times 4 factorial. You know why I did that, right? So that 6 factorial can take up 6 factorials. And with that, we're going to be left with what? We're left with 10 times 9 times 8 times 7 over what? 4 factorial. And for 4 factorials, we can reduce it to what? 4 times 3 times 2. We know that 4 here is 1, 4 here is 2, 2 here is 1, 2 here is 1, and then 3 here is 1, 3 here is 3. We'll be left with 10 times 3 times 7. So our answer will be 10 times 3 times 7. And if we do that, 21 times that, we're going to get 210. So there are 210 ways of what? Of selection of numbers, 4 fruits from 10 fruits. If you select 4 fruits from 10 fruits, the possibility of that is in 210 ways. You see how we can do that? Imagine if we are doing it by practical. It will take us a lot of time to select 4 fruits in random from these 10 fruits to get this. But applying the formula makes it a lot easier, right? So the difference between combination and permutation is that permutation, the formula for permutation is simply n factorial n minus arrow factorial. But for combination, n combination arrow is n factorial n minus arrow factorial, arrow factorial. This is what is missing. And mind you, there's a relationship between both, right? The relationship between the combination and the permutation is very simple. Their relationship is that n combination arrow is equal to n permutation arrow over arrow factorial. That's the relationship. In a later video, I'm going to be explaining this in a later video to see how we can get this done. I hope this simple explanation helps you an overview of what combination really is, right? We talked about permutation, talked about combination, and then we've talked about factorials. We're giving examples of factorials, right? In the next video, we'll be doing calculations involving permutation and combination. Haven't done that, you can see that we're good to go from here, right? And then we'll get to Pascal's triangle and see how we can drive from there. I'll see you in the next video, guys. Thank you. All right, so let's get on with these questions we have on the board. By solving this question, I believe you are going to get conversant on how to manipulate between permutation and combination. By solving this, I believe you're going to get good with it, and then we'll proceed to other examples. Number 1 said we should simplify the following. Number 1, example 1. Example 1. Let's simplify 5 combination 3 times what? Times 7 combination 4. I told you the formula now. What we'll do with that is simply 5 factorial all over what? 5 minus 3 factorial, 3 factorial times what? 7 factorial all over what? 7 minus 4 factorial, 4 factorial. By simplifying this further, we have 5 factorial over 5 minus 3 gives me 2 factorial times 3 factorial, and then we have 7 factorial over 7 minus 4 gives me 3 factorial and then 4 factorial. So what I'm going to do, I'm going to reduce this till we get to 3 factorial and cancel off, as well as this till we get to the highest one here. That gives us what? That gives us 5 times 4 times 3 factorial over 2 factorial times 3 factorial, right? Times, for this we have 7 times 6 times 5, right? And then what? Times 4 factorial over what? Over 3 factorial times 4 factorial. So let's get on with it. With that, we have 3 factorial, we take off 3 factorial, 4 factorial, we take off 4 factorial. What do we have left? From there we have 7, is it 7? Sorry, 5. We have 5. This takes off. From there we have 5 times 4 over 2 factorial, which is 2 times 1. And then we have times what? 7 times 6 times 5 over what? Over 3 factorial, which is 3 times 2 times 1. So by doing that, what do we have? You'll see that 3 here is 1, 3 here is 2, and then 2 here is 1, 2 here is 1. Also, we have 2 here as 1, and then 2 here as what? 2. So together, what are we left with? We are left with 5 times 2, 5 times 2 times what? 7 times 5. We cancelled out. Times 7 times what? Times 5. If we multiply that, we have 10 times 5, that's 350. That means our answer, total answer, is 350. So as easy as it gets to the first one. So I'll look at this, try and practice it, and see how it gets from there. Let's try and get on with this question, how to solve question number 2. I'll see you in a bit, guys. Thank you. Alright, so question 2 says for permutation 2 times what? 4 permutation 3. This time we're dealing with permutation, right? So the formula there is 4 factorial over 4 minus 2 factorial. We're not putting any other 2 here, that's for combination. Times what? 4 factorial over 4 minus 3 factorial. So in getting on with this, what do we do? It is simply 4 factorial over 2 factorial, because 4 minus 2 is 2, then factorial, times what? 4 factorial over 1 factorial, not 3. 4 minus 3 is 1, please. It's 1 factorial. Alright, so how do we simplify that? With that, it is simply 4 times 3 times 2 factorial over 2 factorial times what? 4 times 3 times 2 times 1 over 1 factorial. So with that, 2 factorial takes off 2 factorial and 1 takes off 1. So we'll be left with what? 4 times 3 times 4 times 3 times 2. If you try and multiply that, we're going to have 288 as the answer to that question. So look at that and see how we can get other questions as relating to this. We solve them and then we're good to go from there. Next video we'll be treating all of this question. I'll do example 1, example 2, and then I'll let you do example 3. I'll see you next video, guys. Thank you.